Okay, here we will graph one period of the sine and the cosine graphs. One period of the sine and the cosine graphs. Just the parent functions, so that way you can transform them on your own. Okay, so we need to embed this, or I'm going to embed this on the unit circle. So to remind you about the values on the unit circle, if we take an angle of inclination over the x-axis, over the positive x-axis in a counterclockwise direction of some fixed angle, call it theta, then the length from here to here would be x, the length from here to here would be y, and the radius is 1. So notice that any coordinate on a circle with radius 1 then would have the cosine of the angle being the adjacent over the hypotenuse. So x would be cosine of theta. And then your sine of theta would be the opposite over the hypotenuse. So your y-coordinate would be sine of theta. So every point on the unit circle, circle of radius 1 centered at the origin, is a cosine comma sine value. X is cosine, sine is y. So we're going to use the points at 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1 to draw the sine curve now. So let's do this in degree mode since it's kind of at the beginning. So we'll start off with a grid, and when I plug in x equals 0, here I'm going to be graphing y equals sine of x. So to figure out what sine of 0 is, I need to go in my circle to the coordinate at the 0 angle marker and see that its y-coordinate is 0. So I'll go to 0. Then as I incline, I can see that my y values are getting higher up until the top of the circle, which is located at 90 degrees. And at that point, we have a y-coordinate of 1. Then my y-coordinates shrink down to 0, located at 180 degrees. I'll go at 180 degrees. That'll be to 0. Then I'll come down to the bottom. The y-coordinate down here is negative 1, so at 270 degrees, we end up getting a value of negative 1. And then finally, as I complete the circle, come back here, and at 360 degrees, again, my y-coordinate is 0. So 360 gives me 0. So the shape of the sine curve, the y values get bigger, faster to begin with until they balance out near the top. Then they slowly decrease until which chance they speed up as you get close to 180. Then on the opposite side, they get more and more negative quickly to begin with, but then slow down. And then over here, they are slow to begin with and then speed up. And then this is the graph of y equals sine of x from 0 to 360, or if you're in radian mode, from 0 to 2 pi, and then you can just repeat it as many times as you need because its domain is technically infinite. Okay, let's do a cosine graph at the same time while we're here, because cosine, the only difference is it's going to now take into consideration the x-coordinates. So again, I'll go out to 360, 180 is in the middle, 90 is in the middle, that's not a 910, that's a 90, and then a 270. But as I look at this, let's change into a different color so we can see it more clearly. So now I'm looking at the x-coordinates, so it starts at 1. Then my x-coordinates get smaller slowly until which a time as they get 0. So my x-coordinate up here is 0. Then as my angles continue, coming down to here, my x-coordinate eventually becomes negative 1 at 180. And then my x-coordinates, now they're negative 1, but now they start increasing until they get up to 0. We're looking at the x-coordinates. And then finally, still increasing, x-coordinates increasing, up until that x-coordinate of 1 at the end. And so this is what the graph of a general cosine graph, the parent graph of a cosine on the interval from 0 to 360.